All right, to begin with our notes, we are talking rational and irrational numbers. So we need to do a little bit of defining first. In our definition, a rational number is any number that can be written as a fraction. Any number that can be written as a fraction. A rational number is any number that can be written as a fraction. So let's start off with the obvious. If it's a fraction, can it be written as a fraction? Yes, it's already a fraction. So the number 1/2 is rational. The number -84/3 is a fraction. It's rational. The number 4 9/10 it's rational. It's already a fraction. What about a whole number? Like the number 7. How can 7 become a fraction?
7/1.
7/1. 7 is the same thing as 7/1. So what about negative numbers? Can -13? So those are called integers. A negative value. So a fraction is already a fraction. Duh. A whole number like 7 can be a negative fraction. 7/1. An integer, a positive or a negative number like -13 can become a fraction. Can 0 be a fraction?
Yes.
Yeah, I mean, you can earn a 0, right? You can get 0 right out of 10 problems. 0, right? So I'll put the number 0 also can become a fraction. I mean, 0, a whole number has to go over 1, right? But 0 could go over anything. Correct? Okay. So any number that can be written as a fraction is called a rational number. Any number. If it's already a fraction, it's a rational number. If it's a whole number, it's a rational number. If it's an integer, positive or negative, it's a rational number. If it's 0, it's a rational number. So let's talk decimals. Because see how they're in the rational number box? Because they're rational. Remember, the definition, where's my highlighter? Oh, guys. Is any number that can be written as a fraction? Decimals can become fractions. Terminating, what does it mean if it terminates? What if something terminates? What does that vocabulary term mean? Maddie, what do you think? Yeah, it ends. It stops. Terminating decimals stop. They come to an end. Is a terminating decimal, a decimal that stops, is it rational? Yeah, it sure is. If your decimal stops, yes, it can be written as a fraction. The rule is, if the number can be written as a fraction, it's rational. Is a terminating, a stopping decimal rational?
Yes.
Yes. A stopping decimal, a decimal that stops, a decimal that terminates, can be made into a fraction. You read it correctly. You cannot say, oh, 0.5. Oh, 0.07. That's not reading it correctly. Because 0.5 is really what? Which is a fraction. 5/10. Which can be simplified to 1/2. But it's a fraction, right? You wouldn't say 4.763 or 4.763 if we were going to read it correctly. 4 and 763 thousandths. If it stops, if your decimal comes to an end, it stops. It's rational. Because I can read it correctly, and when you read a decimal correctly, it magically turns into a fraction. And a rational number is any number that can be written as a fraction. Terminating decimals, yes, are rational numbers because they stop and they can become a fraction. Repeating decimals. Here's your hint. They're inside the rational number box, so yes, they are too. Repeating decimals have a repeating pattern. For example, 0.242424 ... because it's going on forever. It's repeating to 4. Now, sometimes our calculators round this last digit up because of rounding rules. So sometimes you have to ignore the last digit. But repeating decimals can be made into fractions, and here's how. 1, write it in bar notation. Bar notation. Write it in bar notation. So this fraction right up here would be negative 0.24 because that's what repeats, and there'd be a line over the 24. Write it in bar notation. So this would be negative 0.24 repeating. But we read it correctly. Instead of saying negative 0.24 repeating, what would I say? Negative 24 hundredths repeating, correct? Honey. However, subtract 1 from the denominator. So it's not negative 24 hundredths. It's negative 24 over 99. And that's how you make it a repeating decimal, is by reading it correctly and then subtracting 1 from the denominator. Don't believe me? Negative 24/99 is negative 24 hundredths repeating. So again, you write it in bar notation. What goes under the bar? Only what repeats. Then you read it correctly, and I had negative 24 hundredths repeating. But I subtract 1 from the denominator, so it's really negative 24 over 99. Is a fraction a rational number? Yes. Duh, it's a fraction. Is a whole number a rational number? Yes. Is an integer a negative? Yes. Is a terminating decimal? Yes. Is a repeating decimal? Yes. Sounds like almost everything is rational. If rational numbers can be written as a fraction, let's make a guess, educated guess. Tell me about irrational.
They can.
They cannot. Any number that cannot be written as a fraction. Cannot be written as a fraction. It's decimals that do not stop or terminate. Decimals that do not repeat. Decimals that do not stop. Decimals that do not repeat. There's one very, very, very famous irrational number. Pi. Because pi never repeats and never stops. We approximate pi, but that's because we can't use the real thing, right? Pi. And the square root of a non-perfect square. Square rooting, that symbol, undoes squaring. And remember, we made a list in our bell work of perfect squares. So 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 4 times 4 is 16. 5 times 5 is 6 times 6 is 7 times 7 is 8 times 8 is 9 times 9 and 10 times 10. All of these are okay to be underneath this symbol. Perfect squares can go underneath that square root sign, that radical sign, and it works. Because the square root sign undoes the square. So if I said the square root of 36, I'd get 6. And why would I get 6? Because 6 times 6 is 36. It works. And can 6 be made into a fraction? So this is rational, right? But if I said the square root of 70, that's irrational. It's a decimal that never repeats and never ends. Square root of 70 is 8.366600265 ... It's a non-repeating, never-ending, does not terminate. So this is irrational because it's not in my list of perfect squares.